Well, hi and welcome to my shop, and thank you for keeping me company here today. It's August 5th. It's raining outside. So here I am in my shop, and I have in front of me my favorite workhorse tube tester. This is the tube tester that I normally use all the time for everything. But I haven't been using it lately because it's been presenting some problems. And I want to solve those problems, and I think it's nothing more than broken wires or something like that under some of the sockets, which have become a little bit intermittent. Can't remember though, I set this aside quite a while ago, and frankly I think there was even more going on that made me set it aside. I can't remember, of course. I can't remember. Now, another story to go along with this is these tubes here. These are two 50C5s. One of these tubes is probably gassy. Now this came out of a radio. One of these came out of a radio I was working on a couple radios ago, and I found the grid of the output tube would drift positive, and it seemed like nothing I could do would stop it from drifting positive. Eventually I tracked it down to the tube itself by putting alternate tubes into the radio, and the positive drifting grid problem went away. For some reason, I just couldn't think of gas in the tube. Part of that reason is gas testing is a little more obscure than regular tube testing. The tester I had been using, this one here, this guy here, he does not have a gas test as far as I can tell. I just went through the manual to see about using this for gas testing. It doesn't even have a gas test. Now, there's a bit of a method to detecting gas in a vacuum tube. But this one has incorporated the method. It has a button here, P5, which says gas 1, P6, which is gas 2. Perform the test and observe the direction of the movement of the pointer and the degree of movement of the pointer, and you can determine if there's gas in the tube or not. I have never tested a tube for gas or found a tube with gas in it. So we got two things going here. One is tube tester, got some problems. Tubes, got some problems. Let's see if we can deal with the whole thing here. So the first thing I want to do is just do a regular tube test on one of these, and maybe I'm going to remember right away what the problem is with my venerable tube tester. This is a Stark 966, an extremely popular tube tester in this part of the world. This was made in Canada. There may be other versions of it somewhere else. Maybe they look a little different, have the same circuit in it. I don't know. But here in this part of Canada anyway, or across Canada, this was a very popular tube tester, and still is. I think there's quite a few of these floating around. As popular as a tube tester can be. How popular is that these days? This one was originally owned, now we'll look at this, by the Laredo uranium mines. What would they be doing with a tube tester? Well, they would have had Geiger counters, and the Geiger counters would have had vacuum tubes in it, and they needed a tube tester to check that one vacuum tube. Same vacuum tube, I would think, and they probably had like hundreds of Geiger counters, and I don't know. Don't know much about the Laredo uranium mines. Is it still out there? Are they still digging up uranium? No idea. Okay, so we want to test a tube here. We're going to just pick 50C5. I cleverly have disguised which one is the gassy one. So I don't know which one of those is the gassy one. So we'll just go through the whole process here. In fact, this is suspiciously set to 50 volt filament already, so was it a 50C5 last tested in here? 50C5. The filament voltage is 50. Don't drift up. 50C5. JR2763. JR2763. Guess what? With a 0 at the end? Yeah. So I think I did a 23 on the bias setting. That's 23. And 91 on the English. Yeah, it's set to 91. Yeah. So I guess I did, the last tube I did must have been a 50C5. Ooh, that's not very good. I haven't tested a tube since then. Let's see what happens. So this says the scale setting for the meter. One of the scales here is called English. If you set it on the English scale, you're just looking at the words replacing good. But you can also make direct measurements of the transconductance by setting, selecting an appropriate scale. Like this is a 15,000 scale here. And you can read the mutual conductance, transconductance, whatever you like. I'm usually putting it on a scale and looking for the actual value. The value of GM or transconductance that a tube tester like this will give you is the result of the test they're doing on it. The transconductance is not fixed in a tube. It depends upon how you operate the tube. So if you put the same tube into different tube testers, you'll get different measurements of the transconductance, or mutual conductance as they like to call it here. Okay, so we have this set. We're ready to go. So we're going to stick this in. Now we're going to start finding out if there's trouble in here. Did I just hear a ding, like a bell go off? Was that in my head? So we'll give it a little bit of time here to warm up. Oh, yeah, it's warming up. So gas in tubes, I think it was probably a fairly endemic problem in the early days of vacuum tubes being made for a couple of different reasons. And as tubes got later and later, as in the late 30s, 40s, 50s, they got built in such a way that the gas problem was greatly reduced. That's what I think. I don't know that to be true. I just imagine that's got to be true. You would think in all respects these tubes are getting better and better. Okay, so this guy is going to be warmed up by now. So we will do the short test. Short test is based on a light. Oh. Well. Oh. Where'd it go? Okay, well, something else has entered the picture here. So if it flashes, that's fine. The corner of my eye, I saw this light go. Oh boy, look at that. Can you see that? Sometimes it's dim here. So this is the bad connection for this tube. That's what we're seeing here. For those of you who watch a lot of my videos, you can see I've got this plugged into my box here, but I don't have the dim lights in the circuit. It's plugged into Niagara Falls. So so the voltage is 117, and it's going to stay like that regardless of what's going on here. I saw the short light pop on for a moment. So think loose wires underneath the panel here. And I'd say the heater's off at this point. Yeah. So either the socket is shot itself, it's just come too loose, or there's a wire broken. So what I'm doing is I'm looking to see if the socket wiggles at all. Does not seem to wiggle one bit. Even though the socket is not wiggling, the pins and the sleeve that the tube is going into, those are often loose. And as you put the tube in and take it out, they move a bit. So there's a very good chance there's just a broken wire under here. We're going to have to take a look at this point, because I can't test a tube that's not hot. And it's still flashing. Well, let's give it the test anyway. There's no harm in it. 50 C5 should go 4725 is the lowest. So I better go on the 6000 scale here. 47 would be way up here. So anything below where my finger is would be a bad tube. I don't think it's even going to go at all, because there's no heat in this tube because I think my socket is shot. Okay, that's the story. And of course, this is the socket that's used the most of the time. So I'm gonna take the panel, we'll flip it over, start looking under there, and see what's happening. Okay, screws are out, so let's look under here. Oh, one screw left in. Okay, let's try that again. Very heavy transformer right up in this area here. There we are. As usual, piles of wire. Piles and piles of wire. So I'm looking things over very quickly. It has two tubes in it. Well, that's interesting now. This is an 83. I can see it written back there, and this looks like a 5Y3 or something like that. I thought what was in here was a ballast tube, but there isn't one. A lot of these have a ballast tube in them, which is just a resistor in a glass bulb. Okay, so the particular, this is the one I'm looking at here. So you may just lay this down upside down, I'm pretty sure. There we are. Okay, we need to take a close look at the area in question. Let me switch cameras here. Bear with me a moment while I fix the focus on this. I'm forever never doing this before starting these videos, and it just takes a moment anyway. Okay, I'm going to pull the focus up a little closer. I think I just whoops. Okay, let's try this. The whoops was me setting the camera and then canceling the settings right away. Let's take a look here. Just hang on. Detangling. Okay, the guy in question, I think, is this one right here. What we're looking for is a cold solder joint or anything like that. These look really good. Happening right in there. A couple wires there. So another possibility is that the socket itself has worn out, and I'm secretly hoping it'd be something very obvious. You can see how these will wiggle a bit. The question is, could there be some kind of cold solder joint happening, and you not be able to see it? And I think that's quite possible. nothing obvious. That wire's just going by. Huh. Well, huh. Ha ha. Yeah, so I don't see anything here. They have all these black wires and then one colored one here. One orange one coming over. Oh, there's a blue one. A green one. So I'm sure those colored wires are very significant in the scheme of things. Okay, nothing's showing up. Ooey. One thing I could do is simply just put the soldering iron on all those connections. What else could I possibly do to this that would fix it up? Another possibility, I suppose, is extreme dirt in the socket. When you're plugging it in, it's not making contact, and contact coming and going. I don't know, nothing seems out of sorts here. I got a couple other things I can fix in here too. Let's just take a look, take a little tour here around what's in here. Well, there's a capacitor I put in sometime in the past. The let's say a rheostat variable resistor here. Another one here. Probably shouldn't put my finger on it. What's this guy? This is the light. Another light on the panel here. Look at that. What is this? This arrangement's pretty weird. What's going on with that? Wow. That's a pretty strange arrangement. Never noticed that before. In here, everything else looks good. I don't see any capacitors I would want to jump on and go, ooh, that's got to go. I don't see anything like that. Here's a capacitor here. That looks fine. That's about it. There must be more in here somewhere. That's a little bit on the flimsy side, that. All kinds of... Okay. So the corrosion products I was sweeping off with my finger, that looks like galvanizing, and it's corroding away from just humidity. This is an old machine. It's been around a long time. It's been in my hands for a long time. That's true too. Let's look at these interesting adjustments here. This look like calibration adjustments. Nothing to do with the problem I'm having, I don't think. I don't see how. The problem I'm having is pretty much a socket problem. Well, these are pretty interesting. So you have an adjustment here. You have a wire resistor in here. A resistive element. And you're sliding this to make an adjustment. Though I've never adjusted them. Here's some more. These pieces here. Let's take a closer look at that. It's very interesting. Looks very interesting to me. Let's start with the top part again. Look at the camera's close-up is a little too close, maybe. Is that glue in there, or is that oil? I think it's, this might be glued down. There's the other one. I mean, is that a 100-year connection there? Don't worry, Bill, that'll last 100 years. Loose here. Loose under this nut. And you have this. So this is not an adjustment, this is the termination of the coil here. Ooh. Somebody rough up this coil here at some point? Not sure what they're doing. Don't know what these coils are for. Okay, I guess I really haven't looked this over that closely ever in the past. So what about this up there? Very minor problem here of this terminal just falling out of its hole. How's it held in? It's just using one of these oh, it's broken off. That's what it is. I wonder if I have something like that. I'm gonna scrounge around a bit and see if I have something like that. Here's what I've got immediately available here. So I've never looked at these all that closely. Are these all the same? See, how can I have stuff I don't know what I have? Because twice I have lucked out and acquired the tail end of two stereo shops that closed down back in the 1990s or the early 2000s because of retirement. The guys running them retired and they just shut down their businesses. Now this is a little tiny hole and this has a big one. And then after shutting down their businesses, of course, they hung on to their stuff for some period of time. That's nice. I like that. This looks like it might even fit in the hole. Yeah, it will definitely fit in the hole. I have a red one too. I could change them both. And then we need the right kind of pin to go in it. Here's one. Go in. Now, is there a black one? A black one of these? No, that's a regular meter. Well, anyway, I think I'm going to do that. I'm going to put these in. There's the body. Where's the pin? I guess you probably... Wow. How do you attach the wire to this? Probably unscrews. Don't know. Yeah, so after a period of time, these guys with the stores and their relatives, because I think in one case the fellow had passed away too, and they literally just want to get rid of everything. And eventually, what happened in both cases, they got down to basically the stuff nobody wanted. And then somehow they found me. Hey, you want this stuff? So I'm not going to look a gift horse in the mouth. Sure. So I've brought back boxes of stuff, some of which I have not looked through. Okay, so I have another alternative. I have this style, which is closer to what's in here already. Not really. Not really. Well, I have so many of these guys. I'm going to use these. As for this only having one needle, I'm sure sooner or later I'll find another somewhere. Needle point. Really, can these not go in there? Do I absolutely know they can't? Oh my gosh, they can go in there too. Okay, that's it. Now I'm going to use these two. There we go. Okay, I'm going to change those out inside the thing. What are these? These are the connections for the grid caps. If you need to use a grid cap, either a grid cap or a plate cap, you hook up to these and then put the cap on the tube. That's what they're there for. Okay, I'll make this little repair. Well, I started installing these and stopped right away because these are no good for use in this kind of arrangement. This is a metal panel, and this is really meant to go on a plastic panel because that's the electrode right there. Pretty sure. Yeah, this has to be in contact with this. So can't use these. They're not going to work out. I need one that's plastic through. That's too bad because I got a million of these. I wouldn't mind using a few, but I do have this type, which is plastic. You know, which will do the job for sure. I just have to find some locking screw. A blue one. It's not nice. A blue one. Okay. Okay. Stupid mistake avoided. That would be a really brainless move. I got these terminal ones too, but I think these are over. These are too much. I really need. Okay, I will install the plastic ones. That's what I'll do. Well, don't take this the wrong way, but a lack of nuts has ended up forcing me to put this blue one in here. And going to solder it up. And I have a couple of rules I try to follow, safety sort of rules I try to follow here in the shop. One of them I could have demonstrated with that soldering iron, but I can do it with this. So you're working with a tool, and then you got to do something. So you might just kind of put the tool in the back of your hand and work away like this. This is a mistake. In my case, I was fooling around with this and put this in my hand to do something, and I whacked this bulb with the end of the pliers hard enough I looked to see if I cracked it. The worst one, rule, is this. This is a hot soldering iron here. So you're soldering away, and then you decide, oh, I got to get something. So you kind of grab it and move the soldering iron out of the way of your fingers while you work. It's very attractive to do that, but it leads to accidents. So I try my best not to hold a tool in my hand like that while I'm doing other stuff. Okay, so this turned out to be a time-consuming thing, looking for my nuts. Okay, now back to the problem of the tube socket. And what is the problem? You know what I was going to do? I was going to resolder all the connections on the idea that maybe there's a cold solder joint in there I'm not really seeing, and two, I don't know what else to do, so I'm going to do this. I got to do something before, yeah. Now, next thing I've done is I've lost the solder. Jim, he's lost the solder. Okay, so see, now instead of looking for, oh, you can't see what I'm doing. Put away the soldering iron. Yeah, I'm going to put away the camera too and just do this. Okay, so my expectation is that soldering the wires on the soldering the wires on the bottom of the socket has probably had no beneficial effect at all. Don't drop it, Jim. Down you go. warpage in the box, I guess. Okay, let's try it again. And what we're trying to see is does the oops, sorry about the noise. Does the socket really work? Okay. Again, I can't imagine this made any difference. This particular socket, unlike most of them are riveted in on here. There's rivets holding the socket. This one, it just has a clip up to the bottom. You could pry it off and the socket would come out. It wouldn't be too hard to change the socket. Not that I want to. Now, since it's an intermittent thing, you know, just plugging this in and having it work. I need a little darkness. Give me a little more darkness here. I want a lot more darkness. There we are. There's nothing going on in this tube. Oh, you can see this. So it's the socket itself. Okay, it's the socket itself. What can we do about that? Other than replacing it. Which, goodness knows, I have got 100 brand new sockets I could replace that with. Well, I don't know how many would fit in the hole, actually. Good question. Now, what can you do to fix the socket? That's about all you can do to fix the socket. I can't even see in this one. Like a lot of them, you can see inside. You can kind of see the, you know, but this one, it just has pinholes. Replacing the socket. I mean, it's not a surprise that this would wear out. What exactly would wear out? It's just got to be the springiness of the metal clips locked inside here. How can you be absolutely sure that that's the problem? You would connect a voltmeter to the leads, to the heater leads, and see the voltage at the heater leads under here. In the meantime, the tube is not heating up, and that would pretty much settle it. I think I got to do that before I waste a lot of time and risk the machine here. Okay, so what I've done is I've hooked up a AC voltmeter set to 10 volts on the heater terminals. Don't set it to 10, Jim, it's a 50 volt. 50 volt guy. Okay, so 100 volts, so 50 volts to be straight up and down on the meter. Yeah, I picked a tube with a high heater voltage. I'm just making sure these are not shorted in some way. So you might, oh, that's great, you've got it upside down. How are you ever going to know what's going on with the tube? Because you have to see if the tube is heating. So I have a camera on the tube so we can see if the tube heats versus the reading we get here. I guess another good question is, how do I get my hand under there and wiggle the tube? Okay, we'll experiment with that. That shouldn't be too tough to do. Yeah, I can get at it pretty easy here. Okay, you don't want to cut my camera. Don't cut the camera cord. Okay, I think we're ready. So I just turned the power on. The switch is on already on this, and we should see the voltage come up to 50. Interesting check of the voltage settings here. Here we go. So this is going through dim bulbs at the moment. And 95 volts on it. I'm going to give it the full voltage here. So that is supposed to be 50 volts. The 100 volt scale, it's 40 volts. Now there is a line adjust. These tubes aren't very bright here. But there's the voltage. Now, is the tube lit underneath? We'll take a look. Is the tube lit underneath? I think I should turn this out here. Nope. Who's sending all the light in there? must be the big light. Let's just turn that one off here. Well, I'd say the tube is not heating. So I see 50 volts and the tube not heating. I'm going to wiggle the tube on this guy. A little nervous. Should be watching the voltmeter. We can watch both these things here. Give me 1 second. Okay, give me 5 seconds. Hey. Okay, here we go. Now there's an inset there. Let me just move one camera. You'll see the inset quite clearly. And you can see the tube. And now what am I doing? I am going to reach up under here and wiggle the tube and try to make the contacts, the heater contacts go. And then we'll see the voltmeter. If we're looking at it, we'll see what happens with that. But I can't imagine this is going to drop to 0. It might drop a bit when I get the tube to connect. Okay, let's try it this way. I'm going to, instead of holding it up, I'm going to put a block here. Oh. Now I want to reach under there, wiggle that too. Okay, I'm ready to wiggle. There we go. It went up. How did it go up? Am I wrong about this tube operating? So I'm wiggling it all around. I wish we could see the panel light. The panel light was flickering. You know what else I should be able to see? I should be able to see if I bring in the dim bulbs. I should see action on the supply voltage meters, which are just out of view here. Let me just move this over a little bit. This meter should pop around a little bit. There's nothing happening here at all. What have you done? So did I not connect? Yeah, I definitely connected up to the heaters. Let me change the heater voltage. Oh, I can't do any of this with the way it is. The way it's set. It's too risky sticking my hand in there. Let me set this up differently. This didn't work out. I'm not sure of anything yet. So there's a chance that when I resoldered those wires, I solved the problem. And in fact, the tube is heating up. The tube is warm. If I touch it, it's definitely gotten hot. So so maybe soldering those leads fixed it. And my concern here now is these clip leads I'm using here. They might generate a short circuit in there. It would be unhelpful, that's for sure. Nothing shorted down there. So we're going to turn it on again. I can see the panel light over here. We'll do the wiggle the tube thing again. There we go. It's interesting that this is not actually the correct voltage either. That's really important in tube testing. Really, really important. Okay, is the tube heating up? Let me just turn off my automatic light here. Doesn't look like it. So my automatic light, whenever you're in the room, the light comes on. You cannot keep the light off when you're in the room. I have to unplug it to keep it off. So I'm going to turn it off. It doesn't look like it's heating to me at all. It does not look that way. I'm pulling the plug on the big light. Okay, we can just go with these lights. Hey, I can see the panel light from here. That light you see is this light here is the panel light. So we're going to watch it because I could see the panel light flickering, which is usually the sign of making and breaking the heater contact. Let's see if it flickers here. I'm moving. Oh yeah, look at it. Look at it go. And you know what? The dim bulbs are going too. watch my dim bulbs as I wiggle this guy. Yeah, that's what I was looking for before. You can see this, I don't know if you can see the meter down here. I'm jumping around too. So it's making and breaking. Meanwhile, the voltmeter, which has become invisible, what's the voltmeter doing? So let me reach around to the tube again. Wow. Oh my gosh. Is that when it's on? It's way off voltage. Oh, that's got the dim bulbs in. Da, 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 da. Okay, take out the dim bulbs. Now, wiggle that tube around. So, looks like it'll get up to 50 open circuit. But connect the tube and it drops way off. Wow, that's a bad thing. Now I can get at the filament setting switch here and snap it up one, but I think the jump is pretty big. From here, I gotta read it. I'm gonna use the camera. Might be easier to do it with the camera. So the next setting up, $75 volts. So we go from 50 to 75. Well, I can do that briefly. That won't hurt tube at all, especially if it's low already. Put that camera in this exciting location. Give me more light. And to grab that control and snap it up one more. Oh, I'm so blind in here. New glasses are ordered. They're coming. This one. Okay, we're going up 75. What does the meter do? Goes up to 50. So you know, like, is this a better voltage to test the tube at than that? Questions, such questions. You know, for the most part, tube testers, you know, in the kind of work I'm doing, just repair work, is kind of a go, no-go sort of thing. You're not really looking, you know, to measure the GM or anything like that. So even a tube tester out of calibration is still very, very useful. Okay, I am reaching the conclusion the only way to deal with this is to replace that socket with another socket, and that's going to be a big journey in itself. Well, here's my unexamined collection of tube sockets. I've never gone through these in any kind of detail to look at them, and so the name of the game is to find one that's similar to the one that's in here. That's this one right here. Yeah, similar. There's not much room in there either, so any larger one. See, this one's got the rivet wings on it. These are all going to have like rivet or screw rings on it. You know, would that fit in the hole? Am I going to have to drill a bigger hole in there? I can't do that. So I guess what we'll do is, so this one looks pretty ideal. Again, it's got the wings for it, and they're all going to have that, I bet. But I bet you that would fit in there. I bet you there's room for these to stick out. You know, this might be perfect. It's nice looking too. I like a nice looking one. Okay, so that's the name of the game anyway. I think, you see, this one has these grounding terminals that are going to interfere terribly. This one doesn't have that. Is metal bracket of any significance in any way? I don't think so. It's not connected, and even the center terminal is also just electrically open. Oh, here's one of these really cheap. These are cheap. These are bad guys here. See, they have two pieces here put together, and of course the terminal is kind of traveling in between these two pieces. What happens, these guys get hot over a long period of time, they can build up carbon inside and start shorting out inside. And that's actually fairly common for this particular style. Junky style. Over here. You have all kinds of them. Here's another. This is like a big version of the junky style. Looks like this one came out of something. Yeah. It's not brand new. Look at that guy. This is really old. This has got to be out of the 30s, maybe even older. Lovely collection of. I'm lucky to have these, although I've done almost nothing with them. Look at the big shell on there. Hey, what are you doing in there? Well, I guess that's the socket for a magic eye. Okay, you belong there. I'm gonna put this one aside so I don't drop it back in. These are like this. I think is a really high quality stuff. I think many of them are collared like this. You just pop that collar off? I don't think so. Why would I want to do that anyway? Look at this one. Oh, this one's even more suitable for popping in. Except this grounding piece here. I guess this would slide up against the frame of the tube tester. That wouldn't be a problem. Well, this one's possible. I'm going to put that one aside. What other surprises have we got in here? That's another one like this one, isn't it? They're both the same, yeah. Hey, there's a bag. Oh, I got a bag of them. These have all got the wings for riveting. My God, I tell you, maybe I got the best collection of brand new sockets in North America. Who knows? Here's another one that you can push right in there. It's similar to this one. Well, it's more than similar. It's identical. I got a bunch of those. Look at that. Okay. That's great. What's over here now? Big honking ones. That's been in a radio. Somebody's yanked the rivets out. That's too many pins. Oh, these have all come out of radios. Not this one. This one's brand new. That's another nice one there. All kinds, and these are the bigger ones. I should sort these properly. Big and small. I don't think there's going to be anything in here that I'm going to want to use. I'm thinking things even though I'm not saying anything. I don't think they're going to fit. Okay, enough of this. What about this tray? This has come from a different source. This is pretty interesting. That looks like something that should be in my tube tester. Some light bulbs. I didn't know they had light bulbs here. And then these sockets. Another cheapo. These are all 9-pin. But this one's not, is it? No, this is a 7-pin here. I didn't want to use it, so I'm just going to stick them all in there. There's another one you could push in, but it's the wrong number of pins. And that might fit right in the hole, but not very tight. Okay. What are all the... Oh, look at this. This is nice. For going on the grid cap. And then there's spare, new, or these have fallen out of tube sockets. Maybe they fell out. What am I going to do with those? Just lose them in here? Hey, here's a tube socket. Look at that. Wow. You're not going to see many of these around. In the dying days of tubes, tube manufacturers are trying everything to keep them alive. They're making them very, very miniaturized. Right at the last bit there. I think what I'll do is I'll show the loose stuff, not the neon bulb. Somewhere I've got like 200 neon bulbs. I'll put those in there. There we go. Okay. Kind of sorted out a little better. Look at this socket. Oh, that's not a socket. That's a... What is that? There's no key at the top. There's a key down here. 1, 2, 3, 4, 5, 6, 7, 8. What? 1, 2, 3, 4, 5, 6, 7, 8 pins. They're numbered 1 to 8. I don't know what this is. It looks like it would convert something, but there doesn't seem to be any conversion going on. That's an odd thing. I'm going to put that... I know where I've got a bunch of... I've got a better spot for that. Okay, enough sorting my stuff. Oh, here's another one of these. Well, that's interesting. This one says 22 on it. Very hard to see. 22 right above my finger. And this one says... I'd say it says 23. 23. 22. You got me. I don't know what these are. I'll show you something similar to these I've got. It's a bit of a show and tell thing happening here. First of all, I have these tube extenders somebody was kind enough to send me, and I periodically use these. You plug them in, you plug the tube in here, and then you have these contacts that you can make tests on. Tube extender. So these are converters converting this thing here. 4 pins on the bottom, 8 on the top, or 6, 7 on the top. Hey, there's another one of these. I think I'm going to put this in here then. Another one of these. You know, this might belong to some kind of... Look at the size of this thing. It's only going in. It's not going in a regular socket, that's for sure. So I'm going to call these things similar to these guys. I don't get it. But I don't have to get it. Okay, so I have some possible sockets over here. Two different types. Oh, this one's got wings on it. Why did I pick that one? I'm going to rip the wings off it because I was impressed for some reason. Well, you know, I did say it. The wings could stay on. You just put this in the right angle. And maybe I'm going to end up epoxying that into the thing or something. How am I going to attach it? The one that's in there, it's very hard to see. Has a ring around it. You know, one of those rings you push on. It has teeth, angled teeth, so you can push it on, but you can't get it off. That's what's holding that on. So probably fairly easy to pry that off. Look at all those wires. I cannot get one wrong, and they were nice enough to make them almost all black. Oh boy. So there's a process here that's, if I follow one method, I'm gonna run a higher risk of making a wiring error. If I come up with other methods, maybe I can come up with something that the chance of making a wiring error is low, like transferring one set of wires at a time to the new, and you know, how would you ever do that? Gotta think about it. This is a big project for me. Yeah. Okay, here's my procedure. I'm first going to photograph as best I can as much detail of the wiring around here. All these black wires are a disaster trying to work with them. So you get a really good collection of photographs showing it as in many angles as possible. Next thing is I have to preserve the wires here. If I were to cut them all off, then I'd have to strip them all, and you know, that's not going to work out very well, that's for sure. I have to strip them before I connect them to the new socket. That's not going to work out. So I have to desolder them and pull them off. So I think the next step after photographing it would be to remove as much solder as possible using a solder sucker and other techniques to get rid of as much solder as possible, and then attempt to literally unwind the wires from the terminals and leave the bare wires available. I figure in the course of doing that, I'm going to end up moving these wires all over the place. And looking at the photographs subsequently might be problematic in terms of figuring out what wire goes where. Simply because I will have moved these around so much that nothing will match the photographs. It's a little scary going in. You can't make one mistake. You make one mistake, you might do damage to the tube tester, and just end up far worse off than the situation is right now. Or is there another entire alternative? Didn't I find some new pins here? I have new pins. I don't think there's any chance of replacing one of these pins. I can't imagine how that could possibly be done. Yeah, I wouldn't even know what I would. No, that's not happening. So I have to get the locking ring off. The locking ring has to come up. No, that doesn't actually. The locking ring could stay back there if I can push the socket. Push the socket through. That would take a lot of working. Again, I'd be messing up these wires here. Another possibility would be every time I remove a wire, I label it somehow. Yeah. Another thing would be to make a diagram of the wiring here, a pictorial image of the wiring. There may be a schematic, or there may even be a pictorial image in the information on this tester too. Yeah, I should really look for it, because maybe there's something important there I should look at. So maybe there's a wiring diagram or a picture which would be helpful here. Chance of making this work and getting a good result in the end is actually kind of low. There's too many things that can go wrong here, not the least of which is you can't even fit this in. And actually, I'm using this one here. I can't even fit it in. Or it goes in and it's loose. You know, all those kinds of problems. You know, how does this kind of even lock in? I don't know. You push one of those rings up onto the bottom of this. I don't know. I'm not going to rush at anything, that's for sure. So I'm going to call this the end of this video. I'm going to post this one with the situation the way it is, and I don't know what I'm going to do. You know, I do have a dozen tube testers here. I have a dozen tube testers. Why am I worried about this one? Because this is my favorite. This is my favorite tube tester. Okay. Lots of ways for this to not work out. Hey, thanks a lot for watching to this point, and I don't know what I'll have in here tomorrow. More of this or something else, or I'll be explaining what went wrong. I don't know. Have a great day. The rain is quitting outside. All of our furniture stayed out in the rain last night. It's all soaking wet. So maybe by later today I'll even be able to sit down on my deck. I don't even know. Thanks a lot for watching, and see you on the next video, whatever it is.